Hello students, welcome back to my channel. We will continue our exercise from continuity at a point. So here in question number 1 we have to check the continuity of the function at x equals to 5. So as usual, first let me draw a number line and let me mark my critical point, that is 5 here. And when the value of x is not equal to 5, that time the function is x square minus 25 over x minus 5. That means when x is less than 5, then function is x square minus 25 over x minus 5. And when the value of x is greater than 5, that time also the function is x square minus 25 over x minus 5. And at this particular point at x equals to 5, the function is equal to 10. So since the function is not changing on the left hand side and the right hand side of 5, so we will directly calculate the limiting value. So here limit x tends to 5, f of x will be equal to limit x tends to 5 x square minus 25 over x minus 5. Now here if I put directly the value of x as 5, then it will become 0 over 0, which will be indeterminate form. So first we will try to simplify the rational function. So here x square minus 25 can be written as x square minus 5 square over x minus 5. So this will be equal to limit x tends to 5. So this is x plus 5 times x minus 5 over x minus 5. So here x minus 5 and x minus 5 gets cancelled. So it will be equal to limit x tends to 5 x plus 5. Now let us put the value of x as 5, then we will get 5 plus 5, which equals to 10. Now next I will be calculating the functional value, that is f of 5. And since when x equals to 5 the function itself is given 10, that means f of 5 will be equal to 10. So here the limiting value is 10 and the functional value is also 10. Since limiting value is equal to functional value, that's why therefore fx is continuous at x equals to 5. Question number 2. The function fx is 1 minus cos 2x over 2x square when x is not equal to 0, and the function is 1 when x equal to 0. So I have to check the continuity of this function at x equals to 0. So here's my critical point. And when the value of x is not equal to 0, then that time the function is 1 minus cos 2x over 2x square, and on the right hand side also I have the function 1 minus cos 2x over 2x square. And at this particular point at 0, my function fx equals to 1. Now since the function is not changing on the left hand side and the right hand side of 0, so we will directly calculate the limiting value here. So here limit x tends to 0, f of x will be equal to limit x tends to 0, 1 minus cos 2x over 2x square. Now if I at this point if I put the value of x as 0, then in numerator it will be 1 minus 1, which is 0, and in denominator also it will be 0. So it will be in the form of 0 by 0, which is indeterminate form. So here we will be modifying the given function. So here what we can do is limit x tends to 0, 1 minus, now instead of this cos 2x you can write the formula of multiple angles, that is 1 minus 2 sine square x whole divided by 2x square. So in numerator 1 and 1 gets 0, then it will be 2 sine square x by 2x square. Here 2 and 2 gets cancelled, so here it will be limit x tends to 0, sine x over x whole square. So this will be equal to 1 square, and that will be equal to 1 since limit extends to 0, sin x by x is 1. So now next we will be calculating the functional value, so that is f of 0. But since the question has given when the value of x is 0, then the function is always 1. That means f of 0 will also be equal to 1. That is, my limiting value is 1 and the functional value is also 1. And since they are equal, that means we say that the function is continuous. Since limiting value is equal to functional value, therefore the function fx is continuous at x equals to 0. Question number 3. My function fx equals to modulus of x minus a over x minus a when x not equal to a, and the function is 1 when x equals to a. So now let us break this modulus function into two parts first. So here we know that modulus of x minus a will be minus x minus a when x minus a is less than 0, that is x is less than a, and this will be plus x minus a when x minus a is greater than 0. I am not writing equals to 0 because at x equals to a we have function as 1. So here x is greater than a. That means if I rewrite the function, given function fx, then it will be fx equals to, see, modulus of x minus a is negative x minus a over x minus a when x is less than a, and the function is 1 when x equals to a, and the function is plus x minus a by x minus a when x is greater than a. Now here we clearly see that this x minus a and x minus a will get cancelled, x minus a will get cancelled, hence my function will be fx will be equal to minus 1 when x is less than a, 1 when x equals to a, and 1 when x is greater than a. Now if we try to find the limit of this function at whenever x tending to a, we see that the function on the left hand side of a is minus 1 and the function on the right hand side is equal to 1, and at x equals to a we have function as 1. So if I try to find the left hand limit, the answer will be minus 1, and if I try to find the right hand limit, the answer will be positive 1. That means the left hand limit and the right hand limit are not equal. That means a limit does not exist for a function at a point, then there is no limiting value, and hence we say that this function is not continuous at all. Question number 4. Find the value of k for which fx equals to sine 2x over 5x when x not equals to 0, and the function is equal to k when x equals to 0, and the question has given already that this function is continuous at x equals to a, and if a function is continuous then limiting value and functional value will be equal. So first we will try to find the limiting value and functional value, and we equate both of them. Here my critical point will be 0. When x is less than 0, then the function is sine 2x by 5x, and when x is greater than 0, that time also the function is sine 2x by 5x, and at x equals to 0 we have given the function fx equals to k. Now since the function is not changing on the right hand side and the left hand side of 0, so we will directly find the limiting value. So here limiting value, that is limit x tends to 0, f of x will be equal to limit x tends to 0 sine of 2x over 5x. So now let us take that 5 outside here. So here it will be limit x tends to 0 sine 2x over x. Now since the angle inside sine is 2x, so I will try to make this denominator as 2x by multiplying with 2 and dividing with 2. So here it will be 2 by 5 limit x tends to 0 sine 2x by 2x. Now as you see, as x tends to 0, 2x also tends to 0. So then it will be 2 by 5 limit 2x tends to 0 sine 2x over 2x. Now the value of this is 1, hence it will be equal to 2 by 5 into 1, which is equal to 2 by 5. So this is my limiting value. Now the functional value, that is f of 0, will be equal to k, because at x equals to 0 the function is k. So this is my functional value and this is my limiting value, and since the given function was continuous, so we can write limiting value equals to functional value, and it will be 2 by 5 equals to k, and hence the value of k equals to 2 over 5. Find the value of k for which the function is continuous at x equals to pi over 2. So here also the question has already given that the function is continuous and we have to find the value of k. So let us mark our critical point. So my critical point in this question is pi over 2, and when the value of x is not pi by 2, that time the function is k cos x over pi minus 2x, and here also the function will be k cos x over pi minus 2x, and at pi over 2 my function equals to 3. So here limit x tends to pi over 2 f of x will be equal to limit x tends to pi over 2, the function fx is k cos of x over pi minus 2x. Now since k is a number, so we will take k outside the limit, so it will be limit x tends to pi over 2 cos of x over pi minus 2x. Now if I put the value of x as pi over 2 here, in denominator there will be 0 and in numerator also there will be 0. So it is again coming in determinant form. So here we assume pi minus 2x equals to h. As x tends to pi over 2, then h equals to pi minus 2 pi by 2, which will be equal to 0. That means as x tends to pi by 2, h tends to 0. And since the value of h is pi minus 2x, so from here we can write x as pi minus h over 2. So now we will replace everything here, then here this portion will be equals to k times limit as x tends to pi by 2, h tends to 0, and in numerator we will have cos of pi minus h by 2 whole divided by h. So here it will be k times limit h tends to 0 cos pi by 2 minus h by 2 over h, and in denominator also let me multiply and divide with 2. So here it will be, this 2 will come outside, then it will be k over 2 limit h tends to 0. Now see here, cos pi by 2 minus any angle equals to sine that angle. So it will be sine h by 2 on the numerator, and in denominator we have h by 2. And as h tends to 0, h by 2 also tends to 0. Therefore, my limit will be k by 2 limit h by 2 tends to 0 sine h by 2 by h over 2, and this will be equal to k by 2 into 1, which will be equal to k by 2. So now up to now I have found the limiting value, that is limiting value is k by 2. Now let us find the functional value, and to find the functional value we have f of pi by 2 equals to, but the question has given when x equals to pi by 2 the function is 3. That means f of pi by 2 will be equal to 3. So this is my functional value and k by 2 is my limiting value. That means they should be equal because the question has already given the function was continuous. Hence comparing we can say that k by 2 equals to 3, and on cross multiplying we will get the value of k as 6, which is our required answer. Question number 6. If fx equals to this function when x not equals to 0 and fx equals to k plus 1 by 2 when x equals to 0, and the function is continuous at x equals to 0, then we have to find the value of k, and here the options are given. So first let us find the limiting value. So limit x tends to 0, f of x will be equal to the limit x tends to 0 sine of 5x over x square plus 2x. So now let us try to solve this limit, because we cannot put directly 0 here, it will be indeterminate form, that is 0 by 0. So let us simplify here. So it will be limit x tends to 0 sine of 5x over, let us take out x common from denominator, it will be x plus 2. Now let us separate the function, then it will be the limit x tends to 0 sine of 5x over x into limit x tends to 0 1 over x plus 2. So this is the property of limit, we can separate in this way. So now here as you see there 5, and in order to balance I can multiply with 5 outside, okay, and on the second part we can put the value of x as 0 here directly. So it will be equal to 5 limit, and as x tends to 0 5x also tends to 0, so it will be sine 5x over 5x into, let us put the value of 0, let us put the value of x as 0, then it will be 1 over 0 plus 2. So it will be 5 into 1 into 1 over 2. So it will be equal to 5 by 2. So this is my limiting value. Now let us write the functional value, that is f of 0. And at x equals to 0, my function is k plus 1 by 2. Now since the function is continuous, therefore limiting value should be equal to functional value, and my limiting value is 5 over 2, which I have calculated just now, and my functional value is k plus 1 over 2. So on simplifying, k will be equal to 5 minus 1 by 2, that is 4 over 2, and that will be equal to 2. That means the answer for k is 2. So my option D is the correct answer here. Question number 7. Find the value of a and b for which the given function is continuous. Here the question is saying that function is continuous, but they are not saying at which point. Okay, so whenever the function is continuous, that function is continuous at each and every point of its domain. That means here the function is continuous at 2, the function is continuous at 10, and the function is continuous at any number which lies in its domain. Okay, so first let us draw our number line, and let us mark the critical point, that is 2 and 10 in this case. Whenever the value of x is less than 2, the function is 5. So here in this portion the function fx equals to 5, and at x equals to 2 also the function is 5, but between 2 and 10 the function given is ax plus b, and at x equals to 10 the function is 21, and at x greater than 10 the function is again 21. Now since the function is continuous, so it will be continuous at 2 as well as at point 10. So at x equals to 2 the function is continuous. So here the left hand limit is limit x tends to 2 minus f of x will be equal to limit x tends to 2 minus the function is 5 So here the answer will be simply 5. So left hand limit is 5, and the right hand limit x tends to 2 plus f of x, it will be equal to limit x tends to 2 plus the function on the right hand side of 2 is ax plus b. So now let us put the value of x as 2, then it will be 2a plus b. Now since this is my left hand limit and this is my right hand limit and the function is continuous, that means left hand limit and right hand limit should be equal. So hence here we see that 2a plus b equals to 5. So let me write that equation, that is 2a plus b equals to 5. Let this be my equation 1. Now add x equals to 10. Again add x equals to 10. The function is continuous. So the left hand limit at x equals to 10, that is x tends to 10 minus f of x, will be equal to limit x tends to 10 minus the function on the left hand side of 10 is ax plus b. So here it will be 10a plus b. So this is my left hand limit. Now right hand limit will be x tends to 10 plus f of x, and on the right hand side of 10 we have 21. So limit x tends to 10 plus of 21. So this will be 21. Now since the function is continuous, that means the left hand limit and the right hand limit at 10 also should be equal, that is 10a plus b equals to 21. So let this be my equation 2. Now we have two unknowns and two equations, so from there we can find the value of a and b. So now here's our two equations. So let us subtract these two equations. So here b and b gets cancelled. 2a minus 10a is minus 8a equals to 5 minus 21 is minus 16. That means a equals to 2. So let us put the value of a in equation 1. Then we will have 2 times 2 plus b equals to 5. That is 4 plus b equals to 5, and hence the value of b equals to 1. So these are the required answers. The value of a is 2 and the value of b is 1. So this much in this video. Thank you.